Completing the square, solving quadratic equations. In the last video, we learned how to set up the completing the square. In this video, we're going to learn how to use that to solve quadratic equations. So let's see the steps of solving those quadratic equations. The first thing that we want to do is just examine what our quadratic equation looks like. Now, assuming that it is in standard form, it would look something like this. Our ax squared plus bx plus c equals 0. It does not have to start out in standard form for this process to work, but anytime I talk about an a, b, or c term, these are the terms that I'm talking about. In step number 1, we have to divide both sides of the equation by a to make the leading coefficient 1. So when I say divide it by a, I mean that a in standard form. So whatever coefficient or whatever number is in front of my x squared. In step 2, I need to move my constant term, meaning my c term, my constant term or my c term, to the other side of the equation. So we would move it over here, which isolates the two variable terms. My variable terms are the one with the variables or the x involved. So I need to isolate those first two terms, leaving your constant to the other side. In step 3 is where we set up the completing the square process, and that process we learned again in the first video. So we need to put in blanks, and I'll explain that in our first example, and then fill in those blanks with our 1/2 b squared term. When I'm talking about that b term, I'm talking about the number or the coefficient that's in front of the x. Now that you have that completing the square set up, you should be able to factor that into something squared, hence the name completing the square. At that point, you should only have one variable, and that variable should be squared. So you should be able to finish this by isolating the variable and using the square root property. Remember, whenever you force in a square root, you should also force in a plus or minus. And at that point, you should be able to isolate your x or whatever variable you're using in this example. So let's see an example of this. X squared minus 3 is equal to negative 10x. Now, this is not in standard form, which is okay, but I still need to pick out what my a, my b, and my c terms are. First thing I need to pick out is what my a term is, and that's the number that's in front of your x squared. So technically, I have a 1 in front of my x squared here. Now, if this was any other number besides 1, then I would have to divide by it to cancel it out. Since this number is 1, I can just skip step 1. Step number 2 is I need to isolate my constant term on one side of the equal sign and isolate my variable terms on the other side. So I'm going to move my 3 over here, and I'm going to move my 10x over there. And the reason that I'm doing that is because I like my leading term positive. It makes less work for me later on. So I move these by opposite operations. I add 3 to both sides, and I add 10x to both sides. So on the left, I have x squared plus 10x, and on the right, I have positive 3. So I have finished step number 2. I have my variable terms isolated with my constant term on the other side. At this point, I need to put in blanks. Your blanks will always go at the end of both sides of your equation. Now, wherever I put in one of these blanks, I will put the exact same thing in the other blank as well. This goes down to your linear or degree 1 principle. It said if you added something to one side of the equation, then you need to add the exact same thing to the other side of the equation. Well, what do we fill in these blanks with? We need to fill them in with something that's going to complete a square. So we fill them in with this 1/2 b squared. Our b term is the one that's in front of our x variable. So my blank here is 1/2 times my b, or my 10 in this example, squared. 1/2 of 10 is 5, and 5 squared gives me 25. So that's what I fill in both of my blanks with. So let me just rewrite my problem so it's a little easier to read. I have x squared plus 10x plus 25 on the left, and on the right I have 3 plus 25. On the left, I should have a perfect square trinomial, so that should factor as something squared. Again, remember the name of this process is completing the square. So this is a trinomial with no common factor, so you set up your parentheses. X times x gives you x squared, and in your last places, you need something that multiplies to give you 25, but adds to give you 10. And that, of course, will be a positive 5 in both of those parentheses. Now that is identical, so that factors as x plus 5 quantity squared. Hence, you have completed the square. Now we have to work with the right-hand side of the equation, which is pretty simple, just elementary math. 3 plus 25 gives me 28. So at this point, you have finished step number 3. Now, you are down to one variable squared, which means you can solve this process by the square root property. Now you must use the square root property here, otherwise it defeats the purpose of completing the square. So at this point we need to force in a square root on both sides of this equation. And when you force in a square root, you should also force in a plus or minus. On the left, the square and the square root cancels out, leaves me with x plus 5. On the right, we have plus or minus square root of 28, which does simplify, splitting it up into 2 square roots. 28 divides by a square. The largest square is 4, and 4 times 7 gives me 28. So moving over to my right-hand side here, I have x plus 5 is equal to plus or minus. Square root of 4 gives you 2, and then you have your root 7. At this point, we need to isolate our variable completely, so we subtract 5 from both sides. And we have our final answer of x equals negative 5 plus or minus 2 square root of 7. So we have solved this problem using the complete the square process. Again, this process is not my favorite process, and I will hardly ever use this process to solve a quadratic equation, but it is good to get familiar with it now, so when we see it in graphing quadratic equations, or when you see it in solving problems in trigonometry, you are one step ahead of the game. My second example of this, 4x squared is equal to 8x plus 5. I suggest you pause the video and try and work this one on your own. Our first thing that we need to do is divide by our a term. Our a term in this example is 4. So we divide both sides of the equation by 4. On the left, the 4's cancel out, which leaves us with x squared. On the right, that actually means we have to divide both of these by 4. And if you don't see that right away, then split it up. We have 8x over 4 plus 5 over 4. Now simplifying this, 8 divided by 4 gives me a 2x, and then I cannot reduce my 5 over 4, so I just have to write it as is. At this point, I'm done with step number 1. At step number 2, I need to get my variable terms together on one side, meaning I need to get my x squared and my 2x together on one side, and I need to get my constant term on the other side. The easiest way to do this is to move my 2x to the other side. That leaves me with x squared minus 2x on one side, and that leaves me with 5/4 on the other side. So I have finished step number 2. Now I'm going to put in my blanks here, and I need to fill in both blanks with the exact same thing, and that is my 1/2 b squared. And the reason that I need to plug that particular thing in there is so I can set up completing the square. My b term in this problem is a -2. So I have 1/2 times my -2 squared. 1/2 times -2 gives me -1, and -1 squared gives me a +1. So that's what I fill in both of my blanks with, a +1. So let me rewrite my problem. I have x squared minus 2x plus 1 on the left, and on the right I have 5/4 plus 1. On the left, you should have set this up as something that factors as a square. Again, remember the name of this process of completing the square. So let's factor that. I have x times x to give me x squared. I have 1 times 1 to give me a 1, and these both need to be negative. So my outside is -x, my inside is -x, so together that gives me my middle term of -2x. Combining these together, that gives me x minus 1 quantity squared. Now my right-hand side of the equation. I need to add these by using a common denominator, which is 4. So I have 5/4 plus 1 I can convert to 4 over 4. That's just using simple fraction properties. Adding the top, 5 plus 4 gives me 9, and putting that over my common denominator of 4. At this point, I have finished step number 3. Step number 4. I need to solve this one by using my square root property. I have a single x squared. So to get rid of that square, I square root both sides, and don't forget to put in the plus or minus that goes with it. On the right, my square and my square root cancels out, leaves me with x minus 1. On the left, I have positive and negative. Now I can square root each of those individually. On the top, square root of 9 gives me 3. On the bottom, square root of 4 gives me 2. Now I can isolate my variable, and I do that by opposite operations. I need to add 1 to both sides of this equation. And that leaves me with x is equal to positive 1 plus or minus 3/2. Now, since this is all pretty or nice numbers as I like to explain it, I can actually simplify this farther. Split this up as 1 plus 3/2 and 1 minus 3/2. That leaves me with x is equal to positive 5/2 and x is equal to negative 1/2. This is a degree 2 problem. I should have 2 answers. And don't forget, if you ever want to check to make sure your answers work, you can always plug that back into your variable at the beginning of the problem. If the homework asks you for the solution set, don't forget to put the braces around your answers. I'm going to stop this video here. In my next video, I have one more example, as well as I have something else that you might be interested in.